Lesson 4.4, sketching graphs of polynomials. Our learning target is I can sketch graphs of polynomials. Okay, so our warm-up, go ahead and pause this video and try and do the warm-up yourself. Given the following, identify the degree. If you don't remember how to identify the degree, remember for the degree, we need to count the exponents on the x's, or count the number of x's. So there's really a 1x here, and this guy is really being rewritten as x plus 4 times x plus 4 because we have this x squared. So there's a 1, a 1, and a 1. So I have a degree 1, 2, 3. Degree of 3. And my leading coefficient, I just want to know if it's positive or negative. So let me zoom in a little bit. I just want to know if I'm positive or negative. So right here, am I positive or negative? I'm positive. So if I am odd positive, my end behavior is going to look like this. Okay. So get that note sheet out and remember that as x goes to infinity, f of x goes to infinity. And as x goes to negative infinity, f of x is going to go to negative infinity. Okay. My roots, I set each of these equal to 0. X minus 3 equals 0. We've got to add 3 to both sides. So one of my roots is x equals 3. And then set this equal to 0. X plus 4 equals 0. And x plus 4 equals 0. Subtract 4 from both sides. X equals negative 4. Subtract 4 from both sides. X equals negative 4. I only need one of them because that means it's a bounce since there's 2. Great. So let's go down here. For the following, state the degree, the x-intercepts, the end behavior, and the number of turns, number of max and min, number of min, and graph it. So there's a lot going on here. Our degree, remember we count the amount of x's, so I have 1, 2, well that gives me 2 more, so 1, 2, 3, 4. So I have a degree of 4. And is this a positive or negative? Or positive. Okay, I'm just going to write that down right next to it because we're going to need that for end behavior. And then my x-intercepts and roots, I just have to set these equal to 0. X plus 3 equals 0. X minus 4 equals 0. X squared minus 49 equals 0. Subtract 3 from both sides, I'm going to get x equals negative 3 for one of them. Add 4 to both sides, I'm going to get x equals 4 for one of them. Add 49 to both sides. I get x squared equals 49. Well, I don't know what x equals yet, so I have to square root both sides, so I get x equals plus or minus 7. Okay, so if I have 4 roots, and I'm trying to find my number of turns, remember your number of turns is your degree minus 1. So if you forget that, you can go ahead and write it to the side. It's your degree minus 1. Your number of turns is your degree minus 1. So if my degree is 4, my number of turns is going to be 3. How many max and mins do I have? Well, I don't know that until I sketch the graph. So let's figure out the end behavior, sketch the graph, and then figure that out. So remember, if I am positive, and then my degree is 4, so I'm positive even, my stick figure looks like this. So this is as x goes to infinity, f of x goes to infinity. So I'm getting further along on my x's. I'm going higher and higher on my function. And then as x goes to negative infinity, f of x is going to go, well, as we're going further negative on my x's, I'm going to go further positive with my function up to infinity. So let's plot our points. We're at negative 3, positive 4, and then plus or minus 7 is telling me over here at negative 7 and over here at positive 7. So remember, my end behavior was saying I start up here and then I end up here. So I'm going to start up here somewhere. I'm going to end up here somewhere. So we start and we come down because there's no bounce, and then we turn around and go back up, and then back down, back up. Again, we will approximate where these max and mins are later. We don't know that yet. So how many maxes do we have? Well, this is one max. How many mins do we have? 1 and 2. It would make sense because our number of max and number of mins needs to add up to the number of turns we have. All right, let's do another example. This guy down here, what's our degree? Remember, we count our x's. Well, there's x, but there's 2 x's, and this guy is really being rewritten as x plus 5 times x plus 5, right? So I've got 1, 2 x's, 3, 4 x's. So I have a degree of 4. And let's find those x-intercepts / roots. So I have x squared minus 9 equals 0. I have x plus 5 equals 0, and x plus 5 equals 0. And if I'm adding 9 to both sides, I get x squared equals 9. But we haven't solved for x yet. We have to square root both sides. So x equals plus or minus 3. So then this next one, I have to subtract 5 from both sides. I get x equals negative 5. And my last one, subtract 5 from both sides, x equals negative 5. Well, these are the exact same. So remember, when we have the same root, we bounce. We also knew we bounced because of this guy right here. That guy told me that we're a bounce on that point. So you have to plot your point right afterwards. Same root, bounce. So plot point and write B. Okay, so you don't forget that. Plot this point right at negative 5, and I'm going to write B right by it, just so I remember where I'm bouncing. All right, my number of turns is my degree minus 1, so 4 minus 1 gives me 3. My end behavior, well, if my degree is 4, and I don't have anything right in front of here, then I'm again going to be an even positive. Okay, so we're going to have 2 that are looking up like this. So my end behavior is going to be the same as the top. So as x goes to infinity, f of x goes to infinity. And as x goes to negative infinity, f of x is going to infinity. So let's plot our roots. We plot them at negative 3, positive 3, because that plus or minus gave me negative 3 and positive 3. And then remember, we're starting up here, and we're ending up here. So we come down. If there's a B right there, okay, there's a B right here, so it means I'm going to come down, I'm going to bounce. I don't cut through, I'm going to bounce and go right back up, and then come down here. I am going to cut through here because it's not a bounce, and then I go right back up. So that's what my graph will look like. Okay, well, let's go to identifying key features given a graph. When we're finding the degree given a graph, if you don't remember this, finding the degree given a graph, you're going to count your turns and add 1. Oop, count your turns and add 1. So how many turns do I have? Starting at the top, I'm going to go down. Here's 1 turn. Here's 2 turns. And here's 3 turns. If I have 3 turns, I'm a degree 4. If I'm a degree 4, technically that tells me I have max of 4 roots, right? But I'm only crossing the x-axis twice. So that means this turn right here gave me imaginary roots. So let's go ahead and write those down. What are our real roots? Well, I'm at negative 1, 2. So x equals negative 2. And at 1, 2, 3, positive 3. How many imaginary roots do we have? I just want you to identify we have 2 imaginary roots. Okay. And then let's work our way back up. What's our y-intercept? Let's see, down at negative 6. How many maxes do we have? We have 1 max. How many mins do we have? 2 mins. So my end behavior, this guy, it looks like this stick figure. Boop. So find that on your sheet. And we know that as x is going to infinity, my function is going positive. Okay. But then as x is going to negative infinity, as it keeps going to the negative, we're still going positive. And our last example, and then I will see you guys in class. Let's find our degree. Remember, we count the turns and add 1. So I have 1 turn, 2 turns, 1, 2 turns. So my number of turns plus 1 gives me a degree of 3. Well, I have a degree of 3, which means I have a max of 3 real roots. Well, I do have 3 real roots. I have 1, 2, 3 real roots. And it looks like those are at, well, if I counted this scale by 1, 2, 3, 4, 5, I don't end up at 5 here. So we need to use our process of elimination and our critical thinking skills to know that this should be by 2, 4, 6, 8, 10. Same down here, -2, -4, -6, -8. So I have a real root at x equals 2. And then over here at x equals -1. And over here at x equals -3. And then if I have 1, 2, 3 real roots and I have a degree 3, I have none. I have no imaginary roots. My y-intercept is down here at -2, -4, -6. I have 1 max and 1 min. And then end behavior. Looks like this monkey dude. Okay. So that means as x goes to infinity, as x is going positive to infinity, my function is going up to positive infinity as well. But then as x goes to negative infinity, f of x is going to go. So as x is going to negative infinity, my function is going down to negative infinity. All right, I'll see you in class.